If you ever spend a lot of time hanging out with physiologists, and I'm not necessarily recommending this, but you'll notice something, which is physiologists love toilet bowls. They're wild about toilet bowls. They dream of them. They spend their childhood taking apart toilet bowls. When they sleepwalk, they wind up there. They paint toilet bowls. Toilet bowls teach you everything you need to know about the body as far as physiologists are concerned. So here's what happens in a toilet bowl when you take the lid off and you've got your microscope going there. You flush the toilet and you've got a problem. You have a problem, which is a depletion of water. Your toilet bowl is dehydrated. It needs to fill up with water. And fortunately, you have a source of water, which is the source of water spraying the water out thing. You've got the pipe there, which goes and secretes water. And as we introduce a term here that will come back to seem quite relevant, so you've got the first step there in a toilet bowl doing its thing. It secretes something that is necessary, which is water. So water is pouring out, and eventually the water level begins to rise, and there's something in a toilet that senses what the level is of water in the system. The flotation device there, which begins to go up as it heads up there. The next thing you have as a critical feature is a set point in the system, which is an optimal level of water, a notion as to how high water levels should go before you turn off the source of the water, before you turn off the secretion of the water. And the final thing you have is a mechanism that turns the information about water height, that sensor, the floating thingy, and what that is able to do is transduce we've gotten up to the set point level into a signal to stop the source of water. And what we have here is what toilet-oriented engineers might call a negative feedback system, where you send a signal out and you have to have a set point, and when you reach that set point, that turns off the secretion of that. And there's just all sorts of physiological systems that work that way. Your brain decides how much growth hormone you want to have in the bloodstream, one of those hormones, whatever, and it goes and secretes it by way of this sort of whole axes we've heard about. And what it needs to do then is measure how much of the stuff there is in the circulation. It needs a flotation device. And what that is parts of the brain that are sensitive to levels of that particular hormone. There's got to be a set point, some rule somewhere in the part of the brain that initiated the secretion of growth hormone, and there's got to be a way of transducing the sensor signal into shutting off the secretion. There's got to be projections, cables coming out of the part of the brain that's measuring the hormone, heading down onto their negative feedback regulation. And there's all sorts of fancy versions of it. You can have your set point change that happens during the ovulatory cycle, for example. The optimal level of estrogen is very different on day 0 versus day 14. You can have feedback systems that are responsive not just to the level of some hormone, but to the ratio of 2 hormones. Basically, though, it's great. What it is taking engineering principles and sticking it into physiology, showing that these systems make sense, showing that these physiological systems are tightly regulated. Selye loved this subject, and this actually makes a great deal of sense. You're Selye, starting the field in the 1930s, and as we talked about many lectures back, when he first proposed this stress concept, whether you're injured, starving, too hot, too cold, you turn on a very similar stress response. People, physiologists, thought he was out of his mind in the early years, and because of that principle we talked about earlier, when you have a specific problem in your body, you come up with a specific solution, and here's this non-specific stress response thing. Everybody thought Selye was a crackpot. And what they mostly thought was he was a type of crackpot who was not systematizing in his physiology, who was not organized, who was not hard-nosed, who was not following all sorts of rules about how physiological systems work. And not surprisingly, Selye had all this engineering, bioengineering envy. He wished that he could have the credibility in stress physiology of things being as clever and clear-cut as those negative feedback loops and the things that would make engineers happy. Fortunately, in the years subsequent to Selye and stress first bursting on the scene, fortunately, what began to emerge was lots of evidence suggesting that is just how the stress system worked. And this was enormously exciting to Selye and his disciples because the system was making sense. It was a regulated system. For example, you take an individual and experimentally you infuse them with a drug that drops blood pressure a tiny bit. And what you could then see is increased secretion of a hormone that counters this by increasing blood pressure. Now, instead of dropping blood pressure one smidgen and seeing one smidgen of this hormone coming out, you drop it 2 smidgens, and 2 smidgens of the hormone come out, and 3 and 4 and 3 and 4. It was logical. There was this tight regulation. The amount of stressful challenge to the system in a very tightly predictable, organized regulatory way predicted the magnitude of the stress response. And this worked in all sorts of realms. You would stimulate, say, one pain receptor by pressing here, and the stress response of heart rate increasing would be 1 smidgen, and now you stimulate 2 pain receptors and it goes up a little more, and suddenly it was just like the greatest dream come true for the stress physiologist. They had to talk to mathematicians. They had to talk to statisticians. The field was becoming really hard-nosed, and this was wonderful. And Selye, this was just the golden age for stress physiology. And then something happened that ruined all the fun. And this came in the 1950s. You would do an experiment that in the stress regulatory bioengineering world, you knew exactly what was going to happen. For example, you have a test organism, and you do something like what was just described. You have this much pressure placed on a pressure pain receptor, and glucocorticoid levels go up this much, and the next individual you press this much, and goes this much. The usual tight mathematical relationship. But now you do something a little different. And what you show is you have your test organism, and you put in a certain stimulus of a certain intensity, and you've got your calculator and your abacus out there and counting your toes, and as a result you know exactly how much of an increase in stress hormone levels there should be, except something different happens. When you stress this organism, the organism has the opportunity to now get up and run over to mommy and hold on to her, and you don't secrete the glucocorticoids. This was flabbergasting. Nothing in Selye's wonderful, clean world of stress responses being a tightly, logically regulated engineering system as wonderful as a toilet bowl, nothing could have predicted this. This was horrifying. The notion that this tightly regulated system, this organism goes and screws up everything by running over to mommy, and mommy would blunt the stress response. This was very unexpected, obviously, and this was like the worst news that came down the pike for Selye in a long time, because what do you do with this? This doesn't make any sense. Nothing could possibly explain the fact that this tightly regulated world, it was modulated instead by perception, by appraisal, by evaluation. And this was really quite shocking. We've seen one version of how this works, which is these appraisal factors, this world of running over to mommy, could modulate how the body would respond to a stressor. You put in a stressor, and suddenly some weird, untoilet, bullish variable like hugging mommy, and you would change the output. You could modulate the magnitude of the stress response by these appraisal evaluative factors. And there was a remarkable study showing this a few years ago, showing just how much of a stress response you can get. And this was like a remarkable study. This was published in the journal Science some years ago, and it showed some evidence for rat empathy. Here's what was done. You give a rat what's called a hot plate test, which is you put them on a perfectly cold surface, and you slowly begin to increase the temperature of this plate. And at the very point where it's gotten warm enough that the rat picks up a paw for the first time, take them off, and you've just finished the study. You've determined what their pain threshold is for this. And it's kind of distressing, but it's not massively so. So what you see in this study is you're doing this to one rat, and you put another rat right next to it, and you give it the same painful sort of stimulus. And what you see is if the first rat is getting exposed to the stressor, it lowers the pain threshold of the second rat right next to it some of the time. And here was the remarkable thing. Put two strange rats next to each other, and it doesn't work. Put two cage mates next to each other, and you get this empathic lowering of the threshold for the stress response. What have we got there? In rats, something akin to empathy. I know this rat, and this rat is giving off signals of being stressed. I am going to lower my threshold for my stress response. Modulating in the most unexpected realms. Go hug mommy, and you don't secrete as many stress hormones. Go sit next to a rat that you know and liked that's getting exposed to its own stressor. You become more sensitive to stress. So modulatory factors. Then the most outrageous thing came along, people showing that you could turn on the stress response in the absence of any stressor, in the absence of any physical toilet bowl-ish sort of insult of this much of a drop in blood pressure or this much of a stimulus. You could turn the stress response on without anything happening physiologically. And to appreciate that, all you need to do is look at a classic demonstration of that. Sit there and watch a loved one go through a painful medical procedure, and your heart rate will increase, and your breathing rate will increase, and you are turning on a sympathetic nervous system stress response. What is this? This is the very core of this entire course, the notion that we smart humans, and even some other species as well, have the sophistication to turn on the stress response to circumstances that make no physiological sense. We could turn it on in response to psychosocial stressors. This was the establishment that this could go on. And Selye hated this. And during the 50s, there was this sort of wildly florid animosity that evolved between Selye and a man named John Mason at Yale, who was the one who did this pioneering work. And this was the battle between stress physiology as a tightly regulated engineering system and stress physiology as this mucky, weird world of mommies hugging test organisms. And in one very, very widely read debate that the two of them had in press, they slashed at each other and argued about what sort of system the stress physiology system really is. The general consensus is that Mason mopped the floor with Selye because you couldn't look at results like mommy hugging and argue that the stress system is nothing but a tightly regulated engineering wonder. Selye managed to get a couple of hits in there at the end, pointing out there's a few cases where there's none of this appraisal yucky stuff happening. For example, anesthetize somebody for surgery and slice into their belly, and you turn on a stress response. And no degree of mommy hugging them, no degree of framing of the experience, nothing is going to change that. Okay, so some of the time, the stress physiology system was responsive to the pure mechanical magnitude of the stressor, but the general view, though, was in all sorts of realms, the most common realms of the stress response, aspects of appraisal and evaluation and perception would greatly modulate the stress response. What have we just done here? What happened in the late 1950s? Suddenly, through the back door in the whole field, in snuck the psychologists. And suddenly, stress and disease and health was as much the purview of psychologists as it was of these hard-nosed endo-neuro-mechano-engineering types. And thus, the field was changed forever after. And once again, as the very core of this course is the fact that when we think about our stressors, we are dumped into the world of psychology, stress and health, rather than the world of tightly regulated endocrine systems. And Selye was vanquished as a result and apparently nursed a great grudge for the rest of his life about it. For everybody else in the field, slowly those low-class, swarthy, unkempt psychologists slowly, got some manners and some gray hair and eventually were allowed to eat at the dinner table. And slowly, psychology has come to be viewed as at least as interesting in making sense of stress and disease as the purely mechanical aspects. So that moves us now to this critical issue of what is it about psychological context that is stressful? And what we're talking about here is what makes stress when it's psychological stress. We're talking about certain types of stressors. What we just saw was a stressor, a certain degree of stimulation, could be highly modulated by hugging mommy. Nonetheless, there are circumstances where it can't be modulated by psychological factors. Go outside for a walk to the supermarket, unexpectedly get gored by a rhino, and you're going to have a stress response. There's no degree of psychological reappraisal you can do. You can't decide, this is a chance to grow from adversity, or I've always hated the shirt, so now I can finally throw it out. You're going to have a stress response. But when you get to the world of much more intermediate, moderate stressors, the capacity of psychological context to modulate is enormous. So thus we begin with this critical question: what is it about psychological context that makes some stressors more stressful and other ones less so? And what we'll see over this lecture and the next one, there are some very powerful psychological factors that modulate the stress response. First one, in the aftermath of a stressor, do you have an outlet? And this was work pioneered by Jay Weiss, then at Rockefeller University, now at Emory University. And here's the paradigm that he did. And just as a sort of note up front here, the experiments that dominate the next few days the next few lectures, are some rather painful ones to hear about. Hear these in the context of this is where the next antidepressant drug is going to be invented from information like this, psychological stressors. So here is what Jay Weiss would do. He would take a rat who would be exposed to a physical cell-yi-in stressor. Every now and then it would get a shock. And with enough of these, the rat would develop an ulcer. Now there's a second rat. Psychology jargon, the second rat is yoked to the first rat. Every time the first rat gets a shock, so does the second. Same intensity, same duration, same everything. According to Selye in 1930s, the two bodies are being knocked out of homeostatic balance to the exact same extent, except there's a critical difference, which is every time that second rat would get a shock, it could go over to a bar of wood and gnaw on it with its teeth, and it wouldn't get an ulcer. It had an outlet for the frustration caused by this stressor. And what soon emerged was the recognition that all sorts of outlets would work for a rat under those conditions. The rat going into a running wheel after shocks like that and running off the stressor, an outlet in that form. All of these, overeating at that point, all of these would wind up protecting from a stress-related disease. Outlets. And then you look at the same thing in humans and you ask, well, are stressors capable of being modulated, being blunted by outlets and that's hobbies. That's going for a run. That's working off the tension in a gym. That's screaming in the stairwells after that awful stressful meeting. Humans do the exact same thing. Why should this work? Why should physical outlets reduce the stress response after a stressor? For a number of reasons. First off, because it releases the muscle tension, especially if it is a psychosocial stressor. Again, back to the very beginning, what's the stress response about? Getting your body ready to run, to sprint, all of that. And here you are having that all turned on for purely psychological reasons. Go exercise and you decrease that muscle tension. This is found in a particularly interesting realm. Now, throughout the early part of the course, a very similar metaphor kept coming up. The zebra running for its life away from the lion and needs its energy and its thigh muscles. Not all animals deal with predators that way. Consider, for example, gazelle. Gazelle are mostly hunted by cheetah. And what gazelles do, if there's a cheetah around, is they don't run away because cheetahs run faster. What they do is they crouch down and stay as still as possible in the hopes the cheetah won't spot them. In other words, the stress response in this case is not about running for your life. It's about being as still as possible, and if need be, a quarter second from now, beginning to run for your life. And it's a very different physiology, and it is demanding, even more so than the running for your life scenario, this absolute stillness amid this absolute preparative muscle tension. And what do you see after the cheetah disappears and the gazelle has gotten away with it? It gets up and it runs around like mad to dissipate some of that muscle tension. Why else do outlets work? Because they distract you. And that's what some of the most basic human hobbies are about. Why else do outlets work? Because if it's the right kind, they remind you about what's really important in life. They remind you, for example, that at the end of the day of rushing and traffic and striving and ambition and shallow, just wishing, coveting what everybody else has, after a day of that, at the end of the day in those stressors, if it's the right setting, you come home and have the outlet of playing with your children. And suddenly you remember what things really matter in life. So we've got this world of outlets. There's one type of outlet that pops up very frequently, and this is a really distressing one. Now you take the rat that is yoked to the first one, it gets the same shock, same intensity, all of that, and now what it's allowed to do after getting its shocks is run over to the other side of the cage where there's another rat it could sit down next to and bite the bejesus out of it. And you know what? This rat who's doing the biting isn't going to get an ulcer. He's got a particular type of outlet. He's doing displacement aggression onto an innocent bystander. And disturbingly, this works great. Among baboons, about half of aggression is displacement aggression. Male loses a fight, who chases a subadult, who bites a female, who lunges at a juvenile, who slaps an infant. What does that mean? At each one of those steps, an individual is taking the stressor, the frustration of what just occurred, and having an outlet, dumping it on somebody else. And this makes very disturbing sense. This is why during periods of economic duress, rates of child abuse, of spousal abuse go up. This is the world of displacing. Really, really depressing finding, and this came out of some of my work with baboons, wild baboons. You look at being a very stressed type of baboon, a relatively low-ranking one, elevated glucocorticoid levels, you know the whole business by now. And what you see is the greater the tendency that baboon has to dump on somebody else, to displace aggression when something stressful has happened to them, the lower their glucocorticoid levels. In other words, this particular type of an outlet, displacing aggression onto an innocent bystander, is one of the most common and one of the most efficacious things that social organisms do to feel less stressed. Really bad news. And it's the core behind one of the great truisms of stress management: don't avoid getting this ulcer by giving it to somebody else. Next variable, in addition to outlets, here's now the variable. You take the lab rat that's getting the same shocks, all that sort of deal, and now this time it could run over to the other side of the cage where there's a rat that it knows and it likes, and they groom each other, and it doesn't get ulcers. Social support. And harking back to that empathy study, it's not just doing it with any rat. If it's a complete stranger of a rat, the logical thing to do is displace aggression on them. If it's a rat you know, the social support, the grooming there is protective. Same thing in baboons. What you see there is social grooming, and this is one of the archetypal things that non-human primates do, which is sitting around and taking the parasites off of each other and eating them. And what's grooming good for? And all the initial theories were, number one, if you're being groomed, it reduces your ectoparasite load. Number two, if you're grooming somebody else, you get all this great nutrition from eating the little ticks and stuff in your life. That's got nothing to do with it. When you look at how grooming works, what it is social calming. It's stress reduction. You get a baboon who has just had a scare. A lion has almost gotten him. And what does he do afterward? He runs over and grooms somebody. You get the entire troop where something scary has happened. Some lion has leapt out and everybody just barely made it into the trees. And when the lion is gone, everybody comes down and sits and grooms for the next half hour. It is very socially calming. And a remarkable study done a few years ago by Dorothy Cheney and Robert Seyfarth at the University of Pennsylvania looking at baboons and one of the worst stressors that could happen to any female primate, your child has died. And what they show is for quite a long period afterward, elevated glucocorticoid levels in these females, and the more grooming they did, the less it rose. What does it look like in humans? Obviously, this is the whole world of social affiliation, and we are going to come back and look at it like crazy. It's also pertinent in all sorts of very acute circumstances. Take somebody going through a short medical procedure that's kind of stressful. Take somebody go through an experimental stressor, rapid mathematics pressure, and have somebody there they know and like and hold their hand, and they don't have as much of a stress response. Social support as a highly protective factor. Next one, predictability. Predictability. Back to those two rats, both getting shocks, and now the second rat, 10 seconds before each shock, a little warning light comes on. And the rat doesn't get the ulcer. Predictive information. Enormously powerful in that regard. And we know that principle. It tells you when something bad is coming, how bad is it going to be, how long is it going to last, how severe, what it's like afterward. And what that does is it allows you to plan coping strategies. We all know that principle, and we use it all the time. Every time you're sitting there in the dentist chair and you say, "Are we almost done? Give me some predictive information." And we all know the difference between the dentist that says 2 more bits of drilling and the one that says 2, I don't know, you could be here for weeks. What does predictive information do there? Lots of things. One of the things it affords you is the ability to plan your coping strategy during the stressor. And that's one that's very effective. Knowing that this stressor is going to last for 4.5 days versus 3 seconds, that's very useful to know. That allows you to plan your effective coping strategy. And you even see this in the realm, somebody is going through a surgical procedure, and what they tell you is the first day or so, it's going to hurt like crazy, and by the second day, you're just going to be uncomfortable and tired. What that tells you is your coping strategies, you should plan on watching the exciting, tawdry adventure action movies the first day and work on your composing those delicate haikus the second day instead of the other way around. It allows you to plan your coping strategy. What it also allows you to do is know when the stressor is over with, when you're finally safe. For that rat getting the shocks without any warning light coming on, any second you could be a half second away from the next stressor. So this is an extremely powerful principle in terms of being told when is it going to happen, how bad is it going to be, how long is it going to last, and that works as effectively in a human, a non-human primate, a rat. So in all of them, it is a very powerful variable for controlling things. And that whole notion that what predictability allows you to do is know what your coping strategy is going to be, know how long the stressor is going to last. That's the principle behind one of the most painful, one of the most central, one of the most defining, one of the most poignant questions any of us might ever ask somewhere down the line, which is, how much time do I have left? So what we've seen here now is the first of the powerful psychological variables. Powerful, the defeat of Hans Selye, and the psychologists suddenly taking over the whole field. And the starts of these variables, what is it that makes psychological stress stressful? For the same degree of objective challenge to the system, you are more likely to subjectively feel stressed, more likely to activate the stress response, more likely to get a stress-related disease if you lack outlets for the frustration caused by the stressor, if you lack social support, and if you lack predictive information. So at this point, it seems like there's a very clear take-home message from this lecture, which is when stress hits, get as many outlets as possible and get as much predictive information as possible and try to socialize with everybody on earth. And what you're going to see is if that's what you take as the lesson here, it's not going to do you any good. What works, what buffers the stress response, is far more subtle psychological variables. And that's what we'll consider in the next lecture.